the software I'm using only lets me do 5-minute videos. So we're going to continue where we left off on the last one, number 66. We're going to go with letter B. So we're using the equation delta G equals delta H minus temperature times delta S. And so delta G standard again is going to equal 572 kilojoules minus the temperature again is 298 Kelvin times the delta S, which we automatically put over 1,000, 197 over 1,000 would be kilojoules per Kelvin. So we have 572 minus positive 53.34, which gives us a positive number of 518, we'll do 519 kilojoules. That would be delta G. So we see this works out to be positive, and so it's not spontaneous. But if the temperature was higher, it would make this enthalpy term a greater number, so you would be doing 572 minus a larger number. So it's possible that it's spontaneous at high enough temperatures because they're both positive. Okay, we're going to move on to the next problem, and we have number 71. Okay, so we have a reaction here, and it's giving us a reaction. So we have to look up some values to look at how delta G will vary. Okay, so this is a little bit of work. This is making us go back and say, okay, we want to find out what delta H is, and we're going to do products minus reactants. And we want to find out what delta S is. We also do products minus reactants. So we have to look up the values. So we're going to do 3 times whatever NO heat of formation is minus whatever NO2 is plus whatever N2O is, or delta H is. And then the same for delta S's. We're going to do 3 times whatever NO's entropy value is minus whatever NO2 is plus whatever N2O is. And so in our test problem this would be given to you directly, but if you look these values up, the NO value is 90.37. So do 3 times 90.37 minus NO2 is 33.84 and 81.6. Okay, so that works out to be 155.7 kilojoules for the delta H. So this first question is just asking to make a prediction. So we find that delta H is positive. That's endothermic. That's not favorable. However, if entropy is increasing significantly, the reaction could be spontaneous. So we go to the S values. So we do 3 times 210.62 minus NO2's is 240.45 and N2O is 220. And so we get an entropy change of positive 171.4 joules per Kelvin. And so because entropy is positive, it's possible that the reaction is spontaneous. So for letter A, my prediction would be it would be spontaneous at high enough temperatures. I'm going to run out of time here, so I'm going to finish this one, but then I'll continue on the next one.